Assalamu alaikum, students. Let's talk about area of parallelogram and area of triangle. See, you know that how can we calculate area of rectangle? Okay, let me draw a rectangle over here. See, this is a rectangle, right? And we know that what is the area of rectangle, that is length into breadth, right? Okay, fine. See, this is length of this rectangle and this is breadth, right? Okay, so we know that how can we calculate the area of rectangle. So what about parallelogram? Okay, you know that what is parallelogram. I have already discussed this all about this parallelogram. See, this is a parallelogram, okay, which is similar to the rectangle, okay, but there are some differences. I have already talked about the differences between this rectangle and parallelogram. See, this is a parallelogram and we have to find its area. Okay, so there must be some formula like we have in case of rectangle. In case of rectangle, the formula is length into breadth. If we know the length of this rectangle and breadth of this rectangle, will be it will be very easy for us to find the area of a rectangle, right? Now here in case of parallelogram, there also should be some formula, okay, with the help of which we can find the area of this parallelogram. Okay, see, if we do one thing, we will try to draw perpendicular on any side of the parallelogram. See, for example, this is a side, we have to draw a perpendicular on this from the opposite vertex. See, for example, okay, see, you can draw the perpendicular just like this on this side. Okay, so now this is 90 degree. Or you can do one thing, okay, if you select this side, okay, and try to draw the perpendicular, okay, so you can do by drawing the perpendicular on this side also, right? Okay, so what I did, I draw the perpendicular on this side, for example, side AB. Okay, okay, you can also draw perpendicular on the side CD or ED or BC. Okay, now let me cut this part of parallelogram, this triangular part. This is triangular part, right? I will cut out this part of the parallelogram. Okay, see, so what I did, I cut this part of the parallelogram, right? Okay, now that part is here, right? Okay, now try to insert this part on this side. Okay, see how, right? Okay, now I have inserted this part on the side CB. Now, okay, compare these two figures. Okay, now this figure is exactly similar to this one. Now this is rectangle, right? So now this figure, which was earlier parallelogram, now it turned into a rectangle by drawing a perpendicular on this side, okay, right? And then what we did, we cut triangular part from this side and fixed it on this side, right? Now this parallelogram turned into a rectangle, and we know that area of rectangle is equal to length into breadth. Okay, now this parallelogram, area of this parallelogram will be length into breadth. right? So this is length, right? Now in case of parallelogram we call it base, right? And on this base we draw actually a perpendicular, right? Okay, we draw, and this is called as corresponding height. This is called as height. So instead of length, okay, we call it base, and this breadth we call it corresponding height, corresponding height. So area of parallelogram, now we worked out a formula. Area of parallelogram, this is the symbol of parallelogram, two parallel lines and GM, is equal to base into height, right? See, for example, again this is a parallelogram, right? So now we know that area of parallelogram is equal to base into corresponding height, or simply corresponding height, right? Corresponding height, or simply height, B into H, okay, B into H, right? Say for example, now if this is a base, okay, so this is a base, okay, so we have to consider this height, right, from the opposite verticals. Now if this is the base, corresponding height means if this is the base, then height will be this one. This is the height, right? Okay, if this is the base, for example, this is the base, and what we have to do, we have, if this is the base, then its height will be, so the height, the perpendicular should be on this side itself, okay, so that is called as corresponding base. So this is a corresponding base, corresponding height, right? Now if this is the base, right, then corresponding height will be, this will be the corresponding height, right? Okay, so we must take into account the fact that this, the side we choose as a base, on that side, okay, the perpendicular on that side from the opposite verticals. For example, this is the base, perpendicular on that side, okay, this from the opposite verticals is called as corresponding height. Okay, okay, so now area of parallelogram, we know that it is equal to base into corresponding height. That is called to B, that is equal to B into H. Okay, now what about the area of this triangle? Okay, this is a triangle having three sides, three vertices. Okay, what about its area? How can we calculate the area of a triangle? See, for this let me take a parallelogram again. This is a parallelogram, right? Okay, and try dividing it into two parts by joining the two diagonals, two opposite vertices with the help of a diagonal. Okay, see, the parallelogram is now divided into two triangles. This is one triangle. Say for example A, B, C, D. A, B, C. This one, A, B, C. This one, A, B, C is one triangle, and this one, ADC, is another triangle. So that means this is a parallelogram. Now it is divided into two triangles, right? Okay. If the area of parallelogram is equal to area of parallelogram, area of parallelogram is equal to, we know that, base into height, right? So what would be this area of this part? Okay, what would be the area of this part? So that means area of triangle is equal to 1/2 of area of parallelogram, because this is this part, the triangular part, is half of the area of parallelogram, and this is another half of the area of parallelogram. So area of triangle is equal to 1/2 of area of parallelogram. So that means 1/2 of, and area of parallelogram is equal to B into H. That means base into height. So area of triangle can be calculated by this formula, 1/2 of base into height. So its height will be, see for example, this is a parallelogram. See, this is a parallelogram, right? Okay, the height of this triangle will be here, okay, and this triangle, its height will be here. That means exactly the same. This height will be equivalent to this height, right? Okay. Now what we know is that area of triangle is equal to 1/2 of area of parallelogram. That means base 1/2 of base into height. Okay. Now see, let me discuss another important point about these triangles. See, for example, see, this is a triangle, right? See, for example, this is a triangle, right? Say, for example, there is another triangle here. Okay, another triangle, say, for example. So how many triangles are there? Okay, 3 triangles having same base. Okay, for example, this is one triangle having the same base. This is another triangle, right, having same base, and this is another triangle having same base, and their heights, they are on this, they are within the same, within the same 2 parallels, right? They all these 3 triangles have same height, right? You can see here, okay. See, this triangle, all these 3 triangles, they have the same height, and their base is same, and their base is same. Say, for example, B, and height is, they are, their height is also same, right? So that means all these triangles will have the area B into H. Okay, so that means all these triangles, they have the same area, equal area, right? So that means we can conclude one important thing, where the triangles, okay, the number of triangles can be 1, 2, 3, 4, 5. Okay, the triangle is having same base, and within same heights, okay, or we can say within two parallels, same parallels, right? So their area will be equal. So that means area of this triangle will be equal to area of this triangle, okay, and that will be equal to this triangle. All 3 triangles will carry the equal area because they are on the same base and between 2 same parallels, right? That means their height is same, right? So this is quite obvious. The base is same, okay, the measurement of the base is same, and the height is same. Okay, we can say all the triangles, the area of these triangles will be same, right? Okay, in the next part of this area of parallelogram and triangles, we'll be taking some examples, okay, in order to understand this area parallelogram and triangles in some better way, right? Okay, till then, Khuda Hafiz.